Let me go work.
Time to start. Hi everyone. So this is a Bess working group in IETF 101 with two new co-chairs. So thank you to welcome us. So I'm Stefan and Matthew is my new co-chair. So let's start with the not well that normally already everybody know it, but please read it if you don't. Blue sheets are circulating, so please take care that they get back to us at the end of the meeting. We would like to have a minute taker, if possible, to help us. We have many sessions to manage today, and we would like to be able to interact, so it would be really great to have someone who takes some notes. A volunteer? No. John Scudder, would you like to help us taking some notes?
Just remember, if the chairs are taking the notes, they won't be very good, and we might have to make up what happened.
Thanks a lot.
Thank you, John.
Okay, here is our agenda. So we will try to do a quite long working group status to catch up all the work that is currently done in Bess. We would like to do some cleaning, so we will spend some time on the document status. Then Andrew should present a kind of coordination regarding the TCP MD5 option for LDP, which is planned to be deprecated. Then we will have some MVPN drafts and a lot of session about EVPN, talking about Yang model. There is a huge item which is the DF election framework, where we need a consensus on. And also some drafts that are related to BGP load balancing. So a quite huge agenda. So please, presenters, to be on time because we are really full for the session. So personal changes. So as I told in the introduction, you have two new chairs. We already introduced ourselves. We also have a new responsible area director, which is Martin. Welcome, Martin. So status update for the working group. We currently have two documents in the RFC editor queue, the EVPN overlay and the DCI EVPN overlay, which has currently a misref, especially due to the IDR tunnel encapsulation draft, which is still ongoing. Maybe, John, can you tell us where the tunnel encaps draft stands now? Ah.
I actually don't remember the exact status, but it's fairly close to being RFC'd. I mean, I can't remember if I already sent it to the AD and got it back with comments, or if it's almost ready to be sent to the, it's somewhere in that
Okay.
stage. It should be moving forward pretty quickly.
Thank you. We get also the approval by the IESG on the FATPWE BGP. The EVPN prefix advertisement was sent to the IESG. We have also one document ready for submission to the IESG, which is the layer 2, layer 3 VPN multicast MIB. And we have also within our hands some documents that we need to progress, which are post-working group last call, so the optimized IR. So Matthew should do the shepherd on this. The explicit wrapping, there will be a session today on the agenda. And for the MVP and MIB, I think we are waiting for some updates on the documents that should be done, I think, by the end of the month. We have several documents that are also ready for a working group last call. 3 are already known, and there is a new one, which is the DF election framework. And there is a session on the agenda on this one. To give a bit of history for people who missed the discussion on the mailing list, so I requested the offers from the ACDF draft and the initial DF election draft to come with a merge solution. So this DF election framework is a merge of the 2 documents, so the ACDF and the DF election document. We also adopted a document as a working group document, so the EVP and IRB multicast, and we have several documents that should be ready for a working group adoption. If you think they are not ready for working group adoption, so if you change your mind, please advise us. Just one comment on the MSDP SA draft. So normally the poll for the working group adoption ended yesterday, but we received on the mailing list very few replies to the poll. So we would like to ensure that at least people have read the draft and get a feedback. So could we know who has read the draft in the room? Please raise your hand. MSD SA interoperation. Okay. Yeah, very few people. Within these people, who thinks that this document should be adopted? Raise your hand. And within the other people, who thinks, or someone else in the room, who thinks that this document should not be adopted because there is something wrong and there is no interest for the working group? Thank you. It's very important for us to get feedback on the list, because being silent, we don't know if you disagree to get the document adopted or not. So please express your mind, whatever you agree or disagree or even don't care. Yeah.
I was just saying you pulled the room, but as the minute taker, I can't really say.
Okay.
So, I mean, if you want that in the minutes, you got to tell me what to put.
Yeah, we can tell you at the end of the session. Yeah.
Just clarify for those who didn't see it, it was only 3 or 4 that had read it, and only 3 or so thought it should be adopted, and nobody said it shouldn't be adopted, but overall there wasn't sufficient feedback.
Okay, we have a lot of working group documents that are expired, unfortunately, and we would like to get a feedback on each document to see, do we need to progress them? Do we need to drop or park them? So yes, first of all, the MVP and fast failover. So Greg told that he would like to take over and progress the document, which is a good news. So I don't know if Greg is in the room or not. Unfortunately not. For the EVPN inter-subnet forwarding, we would like to hear about the current status because the document is expired.
Right. That's a very important draft, and I was supposed to do it before this IETF and didn't get a chance to do it. And this is one of the things high on my list. Very important draft. I mean, this is the complementary draft to the prefix advertisement.
Okay, so please update it.
Sure. Do you want me to give an update on the EVPN Trill?
Yes, why not? Go ahead.
Yeah, that one, seemed like at the time I did it, that was a long time ago, 4 or 5 years ago. It seemed like the use case has disappeared, or the interest to it has disappeared. So I'm not going to revise it.
Okay. MVPN PEC? Any feedback? Who thinks that we need to park this document? Okay. Who wants to progress this document? If there is no one, the document will be parked. Okay, let's park it. Virtual P. Who wants to take over the work? No one. We park it. Yeah. Adrian?
Yeah, Adrian Farrell. To be clear, are you making the decisions in the room or are you making the decisions on the list?
No, I think we'll poll the list as well. This is just to get a sense of the room. So, yeah, I think
I'm not sure that all the original authors are. Yeah.
Yeah, I think we need to go to the list with a proposal to park if we don't get any interest.
But we may need a feedback on the list. And system requirements? Is there any offer in the room? Okay, EVPN Trill, we have an update. L3 VPN end system? Okay, and VPLS multi-homing?
We're missing Kirati's input. He's the one that's missing on that list. So
Yes, but
Adrian or Juniper guys, if you can squeeze his arm.
But you would like to progress the document? Okay, good to know. So we would like also to get a status of some documents that are not on the agenda today. So first, the layer 3 VPN Yang. Do we have an offer in the room who can provide an update? We received by email a request to try to progress the Yang model as soon as possible, but we would like to ensure that they are really ready. No one? Okay. Layer 2 VPN. I think I have just one slide to display on this one.
Yeah, this is Himanshu. I have an update for the layer 2 VPN. So basically we have 2 updates. Then we now comply to the network instance model, and we also added the interface reference. So the attachment circuits now refer to the interface ref. And I think the authors believe that the draft is complete, and we would like to make a last call.
Okay. Thank you. One comment regarding the Yang models. As a chair, we would like to ensure that all the Yang models that are related to VPNs are modeled in the same way. So I don't know if the authors from the different Yang model, L2, L3, MVPN, and EVPN are talking to each other to ensure that from an operational point of view and configuration point of view, the user will have the same experience. Is this work already done or not?
Yes, we do that.
Okay, because I read really quickly the draft and I see some discrepancy between
Please,
for example, the route target configuration and so on. So maybe you should do another pass to ensure
Okay.
the correct.
Or you may
consistency.
want to address in the list what inconsistency you are seeing, but we
I
have
can.
tried to be consistent.
Yeah. I also would like from these authors to maybe discuss with the routing policy young people in RTGWG to see how the routing policy can be used or extended for the VPN Yang models, because you may need to use export or import policies at a certain point, so you need to know how to do it. Do you need to extend? Do you need to, just discuss with them.
Jeff Hasnett speaking as the policy editor and mostly as a ghostwriter on the L3 VPN draft. The problem that we're going to have with the policy, the generic policy module, is that while we can extend policy elements that can match things, many vendors do very different things in terms of the VPN technologies, in terms of how leaking happens between the various tables. This is one of the problems we ran into, which is simply the routing config module. And they decided to solve the problem by punting it out of their module.
Can't you just agree on some very simple things like setting route targets or something like that?
So the tack that's at least taken into the L3 VPN module is similar to a lot of vendors in the sense that targets become a property of the VRF to some extent. But many people also do policy algebra on top of that to do things, for example, like hub and spoke. So the challenge becomes not just how to make a VRF have the property that allows routes to be attracted to it appropriately, which BGP could pick up, but also how to describe route leaking without formalizing somebody's policy algebra as being canonical.
Okay, thank you.
Just to add that if you meant pegging the L2 VPN or EVPN to the policy, then I think I don't know whether you meant just for L3 VPN or not.
At least for L3 VPN.
L3 VPN, okay. Then, but we didn't. Our drafts have progressed quite well, and we wouldn't want to peg our drafts to the policies. Okay, that's not complete.
Okay, thank you. So next draft, bump procedure updates.
There have been some recent discussions among the co-authors of this draft, and we are going to make some progress on this one.
Thank you. Data center gateway?
Adrian Farrell. Yeah, I would just respond that to fix some silly nit. This is at the sort of stage of building implementation. And is linked to a draft that's in the Spring Working Group that explains how all the pieces fit together. So it has to be sort of seen in that context. But getting there, I think, is the status.
Okay. Yeah. Go ahead.
Oh, okay. The next draft. I was just
go ahead,
waiting for you
please.
to read the slide. The NSH BGP control plane document we think is fairly stable and is now dependent on, well, we'd like it to be dependent on the MPLS SFC work as well. But failing that, it's applicable to NSH on its own. And that also then is at the sort of implementing, getting stability stage.
Yeah.
And then the next one, the best service training document, which I'm not an author of, but I wrote quite a lot of the text. I think you can work that out. That I think is actually in the field. So
it's what, sorry?
In the field.
Okay.
So I think we should be moving that to some form of closure.
Okay.
And perhaps we should get some of the people who have it and are using it to speak up whether it works and whether they need anything else.
Okay, thank you. So we are done with our status. Let's move on. Andrew?
Thank you. I'm here, I'm Andy Malice. I'm here as co-chair of PALS and also representing the MPLS working group. This is not to start a discussion here in Bess. Rather, this is an advertisement for a discussion which will be happening on Thursday in the MPLS working group. And so we just want to make you aware. So if you have an opinion, we invite you to please come to the MPLS working group where the discussion will actually take place. So the issue that we're talking about here is the fact that LDP is currently specified to use TCP MD5 for authentication purposes as BGP used to. Now, in RFC 5925, as I'm sure you're aware, TCP changed to deprecate MD5 and use TCP AO. And so LDP is looking to follow in BGP's footsteps, and we're also working with the security ADs and the security area to determine what's a good cryptographic mechanism, such as, for example, perhaps SHA-128, SHA-256, or so on, to replace TCP MD5. However, this is a bigger issue than just LDP. This actually affects a number of working groups and a number of protocols. They're all up there, so I won't bother reading them to you. And what we're trying to do in the routing area is have a coordinated approach to this. And so, as I said, we're in discussions with the security ADs and the security area as the best way to go forward as well. And as I also said, the discussion will be in the MPLS working group on Thursday. So with that, thank you.
Thank you, Andrew.
Hi, Alberto Rotana, Routing AD. Not a question from you, just another announcement. As long as we're talking about security. Today we had a routing area chairs lunch, because if you have noticed, there have been not only for LDP, but in general for many of the routing area drafts and work, there's been a lot of pushback from the security area. In form of we need better authentication and confidentiality and everything else. We believe, or I believe at least, that many of the reasons that we don't necessarily do or implement is because of operational circumstances, operational issues. So what we're doing is at lunch today, we talked about several things that we want to do as an area. And so the advertisement is to invite you to participate as well. We want to start, well, one of the first steps we want to do is create some type of templates that we can use for security considerations. So that is a lot easier for us to have common language that we not only agree with in the area, but that we agree with the security ADs as well. So that when we say things like we run inside a domain, for example, that we know what that is. Not only that we know, but that other people know as well, and that we have common language for that. So one of the first steps we're going to do is create some templates so that we can go and pick and put into drafts. That doesn't replace any other security considerations that you should have in your drafts, but it's a first step to help you, or to help everyone get to where we want, and to avoid discussions, long discussions with the security area late in the process, right? If we can attack that here or early in the process, it helps us publish a lot faster. Thanks.
Thank you. Next presenter, Jeffrey.
Okay, so this presentation is about a new proposal using how to use the labels with MVPN and EVPN. The co-authors from Juniper and Huawei. So first of all, tunnel aggregation. In MVPN or EVPN, we could use P2MP tunnels, whether it's MLDP P2MP tunnel or RCP P2MP tunnel. We can use one tunnel for multiple VPNs or for multiple BDs. And with that, the ingress PE needs to impose a label that identifies a VPN or a BD, which is broadcast domain, and then impose a tunnel label. Per current specifications, that label is upstream allocated from the ingress piece label space. And that label is advertised in corresponding PMZ routes, or in EVPN case, the IMAP route. When the egress route, egress PE will maintain context label tables, basically one table for each ingress PE, and the entries in the context label table are basically the upstream allocated labels advertised by the ingress PE. So when the egress PE gets a packet, it will first see a tunnel label, and from the tunnel label, it can identify which context label table to use, and then it goes into the context label to look up the inner label and identify which VPN or BD this packet is for. Another case is multi-homing segment support in EVPN. EVPN uses this split horizon procedure. When the egress PE sends a bound packet that it receives from a multi-home segment using P2MP tunnel, it also need to impose a label that identifies the source segment, so that when the egress PE receives that packet, it knows that excuse me, the packet is originally from a particular Ethernet segment, so that it won't send back to that segment. Again, this is also upstream allocated. And it's another form of tunnel aggregation, because a single tunnel, even though it's used for a single VPN or a single broadcast domain, it is actually used for multiple segments. And we need to use the label to identify the segment. So that works in theory, but there is a scaling issue with it. Consider that if you have X number of VPNs or BDs, and you have in each VPN you have Y+1 number of PEs, that means that on each egress PE, you need to maintain X times Y number of labels. And using a concrete example, if you have 1,000 VPNs and each has 1,001 PEs, you will need 1 million label alone just to identify those VPNs. So that issue has not surfaced before because the P2MP tunnel aggregation has not really been deployed. Or maybe the scaling has not come to that step yet. However, via transport is an inherent aggregation tunnel, and it is it's getting adopted. More will be deployed soon. So this becomes a serious scaling issue. Similarly, this is also a problem for MP2MP tunnel. So the proposed solution here is that PEs will coordinate their label allocation. The allocation will be from a common label pool carved out of the downstream allocation label space. This is no longer upstream allocated, and this means simpler forwarding, because you no longer need the context label space, label table. Here we refer that label pool as a domain-wide common block. It's very much like a sRGB block. And in addition to that, they also use the same label for the same VPN or for the same BD or for the same Ethernet segments. With that, we can reduce the number of labels as well. If you have X VPNs, you only need X number of labels. So what if that common block is not large enough? You just happen to have a deployment with where you just cannot carve out a block largely enough. The solution there is that you can use a separate label space. It's very much like an upstream allocate label space, but it's no longer one for each ingress P. You can just say I'll use one or two, just a couple separate label spaces, and all the P's will still coordinate their label allocation from that space. Now, how do you identify this label, a new label space? So in the data plane, the label stack will be like this. At the outermost, you have the tunnel label, and then follow that you have a label that identifies the label space, and that label is allocated from the common block. And then you follow that you have the VPN or BD or ES identifying labels. So what does that means in signaling? So today the labels are advertised in the IMAP route in eVPN case, or in PIN-Z route in the MVPN case, in that PIN-Z tunnel attribute field, PTA field. With P2MP tunnel, it is assumed that the label is upstream allocated. So now, because we are no longer using the upstream allocated label, we need to indicate that this is not from the upstream allocated label space. It's from common block. So we introduce the C bit in the flex field of the PTA attribute. And then if you're not using a common block label, instead you're using a separate common label space, then the PIN-Z route or IMAP route needs to carry an additional extended community. We call it context label space identifier extended community. It is a transit opaque extended community in the form of ID type plus ID type tuple. In this proposal, we're saying that ID type will be 0, just meaning that the ID value is a label from the domain-wide common label block. And if you need even as a segment identifier label, which is ESI label here, then it must be from the same label pool, same label space as your BD identifying label pool or space. With that, we don't need additional signaling. So summary, instead of using upstream allocate labels, we use labels from this common block, and all the P's allocate labels from that common block, and they all use the same label. And then if the block is not enough, we use a separate label table, label space, shared by all the P's. And there are some other more details about situation where you have if you have tunnel segmentation. Those details are explained in the drafts. I'm just going to skip that. So we're seeking comments, and we'll do further polishing. There are some sections that we need to fill in about MP to MP situations. After that, we'll then seek adoption.
Thank you.
Alice, Agency Cisco. Question for the inter-AS option B, when we're crossing different AS boundary, these global label needs to get translated, right? And how do they, if they do, how do they get coordinated?
They either get coordinated across your entire network, or you can just when the border routers switch the label, they can switch to a different common label for the next domain, for the next region.
Do you expect the controller to do that? A centralized controller?
You can have a controller or for each AS or for each provider. something like that. It's not much different from assigning your route targets or route distinguishers.
Right, right. And then if someone has this common pool capability, can stretch this concept and say that they can use it for underlay as well, right? And then we get into different kind of, I guess, territory. Well, that's for a different discussion.
Right. The underlays, the overlay, there are different issues which deal with them separately.
One question as a working group member, do you already have some customers that have these scaling issues?
We haven't seen a customer having this issue already, most likely because the P2P tunnel aggregation was probably not deployed at all. But with beer coming, the beer tunnel is an aggregation tunnel. So as soon as your number of VPNs times number of PEs, if that number goes up, then the problem will show up for sure. If you have a small deployments where the X times Y is not enough, not large, then sure, no problem.
One other question with respect to the point that you brought up in terms of the actual customer issues. Typically, the customers use non-aggregate because I guess in terms of the scale, even though it increases the state in the core, in terms of the scale, it is the number of the SPMC or IPMC tunnels are not that large for them to be concerned. Have you actually seen a scale issue with respect to the some customer deployment that they need to do aggregation?
So as I said, today we haven't seen actual P2P tunnel aggregation yet, probably because they don't have that scale issue yet, or just because so far they can tolerate with that many number of tunnels in their core. But now with beer coming, beer is aggregation tunnel. So you are using aggregation with beer. And so as soon as your X times Y gets large enough, you will have the scaling issue.
Stefan Likowski speaking as a working group member. Beer should normally try to solve some scaling issues that we already have. But here you say that if we are going to deploy beer, we may fall into other scaling issues. So why should we move to beer?
This issue is not caused by beer, it's exposed by beer. So let's say that beer is never here and you're just using P2P tunnel. And let's say if your network can support many P2P tunnels without doing aggregation, then sure, you don't have this particular problem, but you have the problem of that many P2P tunnel state in your core.
Yeah, thank you. Do you have a comment?
So I'm from Cisco. So if you do the aggregation over a single tree like this, you can, let's say, have less state. But the thing with beer is that, well, let's say the downside of that is that you still have flooding, right? All the packets that go over the tree go everywhere. But with beer, you still have very unique, you can identify each destination separately, right? So with beer, you have the advantage of the state and no flooding.
Okay.
Actually, that's a good point. Basically, what ICE is saying with beer, you don't need to do aggregation because you don't keep any state in the core.
Right, I think
you do the aggregation to reduce the states in the core. If you don't keep the state in the core, you don't need to do aggregation.
I'm not sure if that's what I see saying.
No, that was my own perspective.
Okay. All right. So,
Please answer quickly because you are out of time.
okay.
No, I'm sorry, but I have to cut the line.
Well, I think what we can talk about is offline.
Okay, sure.
Just for our information, who has read this document? Raise your hand. Thank you. Next speaker is still Jeffrey about explicit tracking.
Yeah, so this is an update on this explicit tracking spec. Eric is the editor and he has made quite a few changes recently. So this is just an update on his behalf. First of all, quick overview that this draft covers two major topics. The first topic is that the use this PTA in this way that the tunnel type specifies, it says no tunnel information, and then it has the leaf information required flag set. The purpose of this is to provide a mechanism for ingress nodes to learn to find out which egress PEs want to receive the traffic. In the meantime, it is not actually binding the flows to that to any particular tunnel. This provides some useful information for monitoring purpose. And the second topic is a new flag in PTA. It's leaf information required per flow flag. And why do we use that? Let's say the ingress PE that is sending out some selective PNZ wildcard routes, saying that I want to send traffic to star or to a star G flows, and I said that per LR per flows flag. That means that I want each egress PE to send back individual leaf routes for each flow. For example, the ingress can say that SPNZ is for a particular star G or star, but the egress PEs will send back individual SG leaf AD routes. So this kind of leaf tracking at SG level benefits beer or ingress application, because now the ingress PE can use that leaf AD route to know exactly which egress PEs need to receive that particular SG traffic, so you can do more precise replication towards the egress PE. And this is without the need of sending individual SG SPNZ routes. So this introduced some changes in ingress PE processing of the received leaf AD routes. So those are the two major topics. The recent changes basically includes many clarifications and textual improvements. Very much thanks to Stefan for his thorough review as shepherd. And also changes in the way the leaf AD routes are constructed when it is sent in response to this new flag. And we also have a new section detailing how ingress node process the received leaf AD routes because of that flag. So of all those changes, I want to highlight one particular change. Basically, how to make a leaf AD routes indicate that it is a response to that LIR per flow flag. Previously, we used a special RD in the leaf AD routes. There was the more complex solution and with some unintended side effects. So the new way is that if a leaf AD route is sent in response to that leaf information required per flow flag, then it will carry a PTA flag, PTA attribute with that flag set. That PTA was not mandatory before, but now it is mandatory if that leaf AD route is sent in response to that LIR per flow flag. A lot of more details, things, changes in the draft. I'll skip those. So this document will update the wildcard RFCs. It also modifies the ingress node processing of received AD routes. So it will update RFC 6514 and 7524. So with all these changes, we believe the document is ready for working group last call. In fact, this document is deemed as a normative reference to the beer MVPN spec, and which is ready for to go to the RFC editor. So if this document could move through, can progress quickly, that would be great.
Thank you. Any question?
I'm Jirong from Huawei. Comparing to the benefit that the benefit of less routes and less overhead of signal, I am concerning more about the join latency it brings to beer. So my main concern is that if it can be useful when two areas, segmented areas, both use a beer, can this mechanism also useful?
I think you mentioned beer.
Yeah.
Two areas deployed, both deployed beer. That is to say, segmented MVPN, but both use a beer.
Well, I'm not sure if that is relevant here. And yes, indeed, this does work with beer. This solution does work with beer. In fact, it's one of the reasons is
it seems to be mentioned in the beer MVPN draft that it did not work when we use a segmented MVPN.
We will need to discuss that in more detail. It should work, or if there is an issue, that should have been covered. But so on the spot right now, I don't think we have time to go to the bottom. But
okay,
let's talk
you.
offline.
Okay, thank you.
Thank you. Regarding the next steps, so this document already passed a working group last call, and these comments were being introduced as part of the Shepherd review. As a working group chair, I would like to issue a short working group last call of just 1 week. Is it fine for everyone in the room if we go like this? Okay, and Jeffrey also mentioned the relationship of this draft with the beer MVPN draft. There is a normative link between the two documents. The issue that we may have is that as far as we know, there is no current implementation of this explicit tracking draft, which means that based on our Bess policy, we should not progress this document to further step because we don't have any implementation. But this, if we go this way, we will block also the beer document. So we would like to hear from you, but we will also take it to the list. If you agree to proceed this document, so the explicit tracking document without an implementation. So please raise your hand in the room or raise your voice if you are against progressing this document without an implementation.
Is it on a individual? Are you making this call on a per draft basis, or are you saying that let's skip the prerequisite for all drafts?
No, it's on per draft basis and per situation basis. We have discussed multiple options to try to solve this issue, and it looks that this solution of relaxing our rules seems to be the simplest one.
Martin speaking. Just to clarify, Ali, the policy, if I may call it like that, allows the working group to decide whether we want to progress or not a draft without an implementation. So this is not a special case. This is simply raising the awareness of the group.
But we will take it to the list. Jeffrey, do you want an EVPN sticker? Next speaker, maybe Patrice.
Hey, hi, I'm Patrice Brissette. This is for the EVPN Yang. I think it's going to be pretty quick. So we haven't presented last time in Singapore, so I just want to give you a quick update where we are. There's been a lot of work and back and forth among the author. And well, you can read all the things that has been updated here about the Yang model. I think the main one that we have done is we ensure that this model aligned with the network layer model that was proposed by other folks. So that work has been done. And I think from our side, all the author believes that the work has been completed. So we would like to seek for a work group last call. Okay.
Any question? Thank you. Next speaker is Ali.
So this is the Rev 1 of the IJMP MLD proxy draft, which basically tries to solve the issue when you have all active multi-homing in EVPN and you get the IJMP join or leave can get hashed to one of the link to one and arrive at one PE, and the leave can go to another PE. So we're in here, we're trying to solve that issue by syncing the IGMP, S-J and S*J states between the multi-homing PEs. So changes since last revision is basically minor changes. We've expanded the terminology section, and we reduce the selective multicast procedures to that of ingress replication because there was an overlap between for point to multipoint between this draft and bump procedures. And for bump procedures, we're gonna defer the selective multicast to that draft and reference it here instead of trying to cover it in two places. There was a section that talked about the multiple tunnel type discovery. And again, in order to tidy up this draft and get it ready for last call, we decided that it is also missing certain procedures, and it is easier to cover it separately rather than in here. So, and the remaining changes were basically tidying it up on the draft and replacing some of the terminology. We throughout the draft now, instead of pointing to the EVI, BD, we just simply refer to the BD as a bridge domain, because we already know what it in context of what EVI that is. So it has been around this draft for about 2.5 years. It has been implemented by multiple vendors, and we think it is ready for a working group last call, and we like to request a working group last call for it.
Jorge Ramadan, Nokia. Ali, I have 2 comments. So the first one, I was reading the draft this morning again. I found an inconsistency. So the estimate route is sent always by the P, even if there is a local source. Is that right?
And well, for the local source, we are saying that now we're going to be using SPIMC route, and the estimate route is just going to be advertising the information for the join, S-G or stuff.
I understand, but what I mean is, if you have a P,
right,
and you have a receiver and a source in the same broadcast domain in the P,
yes.
If you get a join from the receiver, are you sending the estimate route even though the source is local?
No.
You're not?
No.
Okay, there is
no need to send it, right?
There is a section that says that you should, and there is another text saying that you shouldn't.
So okay, so if you can send me an email pointing that out, I'll take care of it.
Sure.
Yeah, please try to fix it before we go to working group last call.
Well, we had some offline discussion, and Eric Rosen went through the whole thing, and I'm surprised he didn't catch it because he's very slow. Go ahead.
Yeah, my second comment is I also sent a few comments to the list like long time ago, and one of my my comments that it wasn't addressed in the draft is to simplify the IGMP leaf sync procedure. And in particular, there are a lot of use cases where you don't need to have the whole leaf procedure, especially when you have the receivers directly attached to the P, right? Or even the the C that is directly attached supports itself proxy. So in those cases, when you send a leave message, you can simply remove the S-G from the MFIC. You can remove the state, and what that means is that the IGMP leave sync route can be optional, right? For those cases.
For the cases that you're saying that they're only confined to the multi-homing PEs and not to any other PEs, the receivers and sources?
Yeah, no, what I mean is in order to sync the state in the multi-home C, you need obviously the IGMP join sync route and the IGMP leave sync route. What I'm saying is that in some cases, the IGMP leave sync route is really not needed, and it can simplify the procedure. So
if you can, that's fine. If you can
I can
outline what scenarios you have in mind.
Yeah, I can resend that email that I sent.
Okay.
Yeah.
Sounds
sure. Thanks.
Please be quick with your comments.
Yeah. So I just had question for Jorge that. Yeah, it was quick comment on your question.
State your name, please.
Mankamna from Cisco. So quick comment that will it not be very difficult to have selective decision when to sync the leave and when not to sync the leave with respect to implementation? So will it not be a good idea to be symmetric? Or maybe we can discuss offline which case you want it not to be sync. Yeah, thanks.
I think we need to basically see what cases that is and evaluate it, because if we have the mechanism already in place, then the question becomes what kind of simplification we get out of it.
Okay, please discuss and synchronize offline. Thank you. You're also the next presenter.
Okay. This is an old draft, and I've refreshed it, and I think it is already in your queue for the working group last call. Just wanted to go over the status of it. If so, the little bit of history is been around for 5 years, and it got adopted 3 years ago, and it has been deployed also about a few years, and there is not from the previous rev, which was Rev 0 till now, there hasn't, there is no changes, so it is pretty stable, and it is this is basically an important solution in order for the EVPN and PBB EVPN get deployed in a brownfield scenario where you already have VPLS or PBB VPLS and you wanted to introduce EVPN or PBB EVPN into that network. How do we do that without any requirement or any changes to the existing legacy PEs, and making sure that the whole thing works seamlessly. So this draft describes that and has been implemented by several vendors and has been in deployment. So it is in pretty good shape. So it is already in your queue. So,
any question on this draft? Okay, next one. That's not you.
Okay.
This is the DF election framework.
Ah, okay.
Oh, sorry about the fonts. Yeah, it's messed up. Yeah, so the designated forwarder is the P in charge of sending the traffic to a multi-home CE or a multi-home network. And so RFC 7432 basically tells how you should select this DF or designated forwarder. But as we had deployments, we found some inefficiencies in that selection. So my name is Jorge Rabadan, and this is the list of the co-authors. And basically, this is the way we addressed some of those issues that we saw in the baseline 7432. A bit of history. So in 7432, as I said before, we have this designated forward election procedure. This is what we call the default DF election. And it's not only about deciding who the DF is, but all the procedure associated to discovering the Ps, building the candidate list, and of course, choosing who the DF is. And in particular, the DF algorithm that 7432 uses is based on a modulo function between the VLAN and the number of Ps. Now, so more than 3 years ago, we started working on a couple of documents. So one is the DF election document, and the other one was the AC DF document. And those two documents, they were addressing different issues that we had with the default DF election procedure. They, by the way, they may work together perfectly well. So during the ACDF election draft separate review, basically Stefan strongly suggested that these two drafts should be merged. And basically this is the result of it. we merged the content of both drafts, and we clarified the definition of the DF election extended community that we are using to signaling what type of DF election we are doing. And we also added some little improvements that we are going to discuss here today. So the first thing we are gonna basically comment on the HRW, which is part of the DF election draft. And this is Satya.
Hi. In the sorry. Yeah, in the base HRW. Yeah, in the base HRW, what we have is in the hash, the Ethernet segment value itself did not enter into the equation. So what happens is, if you have the same VLANs, exactly same VLANs, configured on different ESS, then the carving will be exactly similar. So the thinking was that if we want a more uniform distribution, then we have to enter the ES itself into the hash. So that's the main change. So I should also mention that in the default 7432, the value of the ES also doesn't come into the modular algorithm. So how we did it is, next slide. So the only changes, as I said, is we put the ES into the hash, and for that, the digest that was just that of the VLAN, we took 14-byte value, which is the VLAN and the Ethernet segment, like concatenated together, and then took the CRC. So that's the change. And so these are the advantages. Like if the same set of Ps are multi-home to the same set of ESS, then whether you use the modulo DF election in RFC 7432, or in fact in the base HRW, they would result in the same P being elected the DF for the same set of broadcast domains. So this can have some adverse side effects on both load balancing and redundancy, because now for every ES it's the same P which is the DF. And so we thought that, okay, if we put the ESI into the DF election algorithm, it will introduce some additional entropy, which will make it more uniform. But there are cases in which one would want the carving to remain the same, in the sense that the HRW actually does a ranking of the Ps, and by this method you would lose that control on the ranking. But that has some specific use cases, which I think in one of the next talks Sandy is going to explain that. So, thank you.
Thank you. Yeah, the second part of the draft, which is coming from the other draft, is the AC influenced DF election. And let me refresh what it is with an example. You have this broadcast domain with 4 different Ps and 2 different Ethernet segments. So let's say that an individual attachment circuit in P2, which is the DF for both Ethernet segments, fails. And what RFC 7432 says is that P2 should actually withdraw the 80 per EVI route for that attachment circuit. But what the RFC doesn't say is that based on that, the Ps that are part of also of the Ethernet segment should actually rerun the DF election and remove from consideration P2 for the Ethernet segment 12. So this is precisely what we are doing with this draft. We are actually taking that into consideration, and we are rerunning the DF election of removing P2 for Ethernet segment 12. Now, that was the initial draft. What we are improving now in the framework draft, in the new merged draft, is that we are also modifying the DF election procedure for VLAN-aware bundled services. And now the DF election is based it's now per ES, VLAN, whereas before it was based on ES, VLAN bundle. So you can actually take full advantage of this capability to detect black holes and solve them. The other thing we are doing now in the framework draft is that we are signaling this capability in a bit in the DF election extended community. And in fact, that DF election extended community is defined in this draft. You have a section that basically shows you the format. It's an already deployed extended community with the type and subtype already allocated by IANA. And this extended community has two fields, the DF type and a bitmap. In the extended community is advertised and processed along with the ES route. And in the DF type, what you encode is the DF election algorithm. So the values we are defining or requesting to IANA in this draft is value 0, which is backwards compatible with the 7432 default modulo DF election. Value 1 is HRW that we are defining in this draft. And we are also allocating value 255 for experimental use. There are other values already defined in other specifications, like value 2 in the preference-based DF election draft, and value 3 and 4. And now Ali is going to talk about some of them today. And for the bitmap, here we are encoding capabilities. So it's not a DF election algorithm per se. It's not choosing who the DF is in the Ethernet segment, but it's actually modifying somehow the DF election procedure. And as an example, we have the bit 25 is actually signaling this ACDF capability, which is compatible with most of the DF election types that we have in the DF type field. And there are also other bits already defined in other specifications. So some conclusions and next steps. So you've seen this is actually a pretty old new document in the sense that it's merged into documents that we've been discussing, and they already even passed working group last call. So this new document, basically what we are asking for is an immediate working group last call. So please read and comment if you have any issues with it, because it should be pretty much be done in a couple of weeks. We should really call for a last call.
Thank you, and thanks a lot for the work to do the merge.
Thank you.
Any comment? Yes, this document is coming from two documents that were almost ready for working group last call. Very few changes have been introduced expect of the merge. So yes, we would like to proceed to the working group last call as soon as possible, because this is an important piece of work and we have a lot of drafts that are coming after. So we need to finalize this one. Thanks a lot for the work.
Thank you.
Next speaker.
Mankamana is going to come and present. I'm going to take a break.
Okay, sure. Thank you for the audience.
Good afternoon. So I'm sure, I think everyone would have question in mind that we already spoke about two kind of different DF election procedure. Do we still need the
Speak in the mic, please.
Okay. So is there really need of the third one? So let's consider that whatever DF election procedure today we have, whether it is RFC 7432 or whatever we spoke in the previous presentation. So the way it works today, if in this topology, C1 is multi-home to P1 and P2, and we have only one VLAN configured there, VLAN 1. So if any IGMP join coming from receiver side, basically it could go to either of the Ps. And we have IGMP proxy procedure, which says that we can sync the join to the other P in the redundancy group. And what is going to happen. And here we can see that P1 has been elected as a DF and P2 is non-DF. So when multicast traffic comes, and it will be P1 who is going to forward towards receiver and P2 will keep dropping. But what is the problem? The problem is the scenarios where there are customers who are provisioning complete multicast traffic in one VLAN. We are actually not utilizing the other link at all. So we are going, always P1 is the one who will be forwarding the traffic, and P2 will come into the picture only in case of failure. So this is where we are coming, that there is a need, can we improve something in the DF election procedure where we can load balance even in this case. So the requirement briefly would be, can we distribute the multicast flows even if the whole multicast traffic has been provisioned in single VLAN? And it should be working for IGMP V2, V3 and MLD V1, V2 receivers. IGMP V1 we are not considering in this document because we don't see any practical deployment as of now. And new DF election procedure, definitely it should have backward compatibility with all of the other DF election procedure. So the way it is, the solution, the way we are proposing, so let's see, we have some unicast traffic flow here. And now there will be default DF election. When I say default DF election, basically we are using the HRW based DF election. And let's say P1 get elected as a DF and P2 is non-DF. For all of the bump traffic, P1 will be the DF and P2 will be non-DF at this point of time. So I have a new membership request coming in, and membership request reaches to P2, and P2 is syncing the join using route type 7 to P1. Now each of the P, they are going to rerun the DF election for this particular SG. And the final state, let's say that for SG1, P1 becomes non-DF and SG1 P2 becomes DF. So it means that if you see the left side table, the forwarding state will be for SG1, P1 will be in the non-DF mode and SG1 P2 will be the DF mode. For rest of the bump traffic, still P2 will be in the non-DF mode. So when multicast traffic starts coming, it will be the P2 who will be forwarding the traffic towards receiver. And in similar way, let's say we have the next SG2 request coming in, and again the join gets hashed to P2, and P2 will sync the join to P1. Again, they are going to rerun the DF election for this particular SG2. And this time SG2 DF becomes P1, and for the same flow, P2 becomes a non-DF. In this case, now multicast traffic will be forwarded by P1. And same thing can be extend for star G as well. So in the next section, okay. So with respect to the solution which we are proposing, it is enhancement of existing HRW based algorithm. And why we are using SG or star G info? Because apart from ESI, EVI info, this is the key information in multicast flow which can differentiate between different flows. And including S, G or star, G info, we are going to get better distribution. Any questions? So in this version, basically we are using the extended community, whatever has been decided in the framework, and we are using one of the type value as a 4 for per multicast DF election algorithm.
Stefanikowski speaking as a working group member. One question: why did you choose to pick a new DF type but not a capability within the HRW DF type?
So the reason for that is it modifies the hash, and it is a new hash, and that's why we thought it is a new DF type.
Thank you.
Sure.
One question again, but it's more related to the DF election framework draft. I have read the draft really quickly, but I don't see that we have a clear definition of what should be a DF type and what should be a capability.
You're right. There is no maybe clear definition, but DF capability works across DF types. Whereas DF type is individual type is exclusive or either this or that. So if it helps, I don't know, do you want to add that to the draft?
Jorge Rabadan, Nokia. Yeah, we can add some text clarifying that. Yeah, the other aspect is GF type defines the algorithm to choose the DF, right? Whereas the capability per se is not enough to define who the DF is.
Right. So capability works in conjunction with type, whereas type can work without the capability. So capability improves some additional aspects of the DF type.
Thank you. You can pick a sticker.
By the way, nice catch. That was a very salient point you caught.
You're the next one.
Okay, now that we
Do
are
you
on
need
the
a pointer?
We are on topic of the DF election. This is another one. We presented that about a year ago, and this is basically an incremental improvement on top of HRW algorithm for faster DF election upon recovery, because the current default-based mechanism runs a timer, and it relies on the timer expiry to ensuring that all the PEs have the same state. To expedite that, we introduced two capability in here, one based on the handshake, so you don't have to rely on the timer, and second, if the PEs have clock synchronization, then the second capability is based on the clock synchronization. What we did in this draft is basically, now that we got the type versus capability straight out in our DF framework, it was very easy to leverage that and use it in this draft. And basically, we are introducing two capability, one for handshaking and one for synchronization. If the PEs, we are requiring that all the PEs in the redundancy group to have this capability in order for it to get exercised. If one of the PE don't have this capability, they all go back to the default mode. What is when I was looking at this draft, I think what is missing is if both capability, both synchronization and the handshake is available, the draft doesn't currently mention which one should supersede. I need to add that to the draft. I'll add it in the next rev. The draft is in pretty decent shape, and it is ready for a working group call.
Okay. Any question? Thank you.
Sure. Do I have the next one?
Flexible cross-connect.
Oh, that's all right. FXC, flexible cross-connect. This is a new service, eVPN service, which is basically a derivative of VPWS point-to-point. What the initial version was introduced in IETF 96 about 2 years ago, and got updated last year. And this is again another draft that has been requested by multiple service provider and has been implemented by multiple vendors. What I did in this draft is clarify some of the terms which I find it, I find it confusing. The draft was talking about the VLAN unaware FXC and VLAN aware FXC, and for the single homing and multi-homing. And I found that confusing, because when you talk about VLAN aware or VLAN unaware, are you talking in terms of the control plane signaling, or are you talking about in terms of the data plane? What I did, I cleaned that up, and right now basically we got only we got two modes. One is FXC, flexible cross connect, and with that one we don't do any VLAN signaling. And then there is a FXC with VLAN signaling, and that makes it very clear that what we are talking about. In FXC, the difference between FXC and VPWS is, in a nutshell, if somebody asks you what is the difference, FXC requires VID or VLAN VRF. It introduces VLAN VRF. So we started with MAC VRF, and then we added IP VRF for the IRV functionality, because we need to do both L2 and L3 forwarding. Here is a VLAN VRF. And one might ask, why do we need a VLAN VRF? Because in FXC, we are aggregating multiple ports into a single tunnel, single service tunnel. So at the egress, when you receive a packet, you need to be able to know, based on the VLAN, which port you're going to. And that's why we need a VID VRF to do a lookup to know what port we are going to. So that's in a nutshell the difference between the FXC and and EVP and VPWS. EVP and VPWS was between two ports. There wasn't there wasn't aggregation. So then when we have multi-homing, then and you're trying to aggregate everything into a single service tunnel, then if one of the port fails, we need to know which VLAN got impacted, and for that we need VLAN signaling, and that's why we call it FXC with VLAN signal. We had a failure scenario section which was pretty slim, and thanks to Jorge, he provided a text, and we expanded it with a nice figure and all that. Thank you. And I think the draft is now is in pretty good shape, because I went through the whole thing and I modified these terminology to make it consistent and to get rid of ambiguity. It has been around for a couple of years, and it is ready for working group call.
Any question? Who has read the draft? Okay, thank you. We will take it to the list.
Okay. I think the last one, right? I got one more.
Yeah.
Okay. So
this is Alice's session.
And this is my last one, so you don't have to worry too much. So this, again, this is one of the drafts that was realized needed some time back, 4 years ago. and we started with the need for a virtual Ethernet segment when we had the Ethernet access and we had a queue in queue, and we needed to, instead of having a physical port, have a logical port because of a service provider requirement. And then it got expanded. We needed to support that for the MPLS and IP network as well. And we added that about 3 years ago. So this revision is just a refresh of Rev 01, and it relative to Rev 01 doesn't, it's just a refresh. The functionality is very much needed, because even when we talk about the DCI scenario, when we connect multiple EVPN DCs over VXLAN or MPLS core, we need to use this notion of the VES, which is described in this draft. Again, it has been implemented and deployed by multiple vendors, and this is ready for a working group call.
Okay, thank you. Stefan speaking as a working group member. I think this is a useful work, especially for VNNI.
Thank you. Thanks.
Who has read the draft? Okay. Thank you. We'll take also to the list.
Sure.
Just a question for you. So you are requesting adoptions for many drafts. Do you have a kind of priority?
I've been asking for working group last call. Do you want to differentiate working for?
No, just for the working group adoption.
Just a working group adoption. Yes, I have a preference. So do you want me? I'll send you an
Yeah.
email regarding
Thank you.
your preference.
Jorge, I think it's your turn.
EVPN control plane for Geneve. So Geneve is the encapsulation backed up by the MVO3 working group, and pretty much EVPN can be used along with Geneve, but we needed to define some specifics. So Sami asked me to present this on his behalf. He couldn't make it to this IETF, so here we go. Yeah, so you can use in Geneve mainly based on what the EVPN overlay draft says, right? You have the basics there, but there are certain things that you need to specify, specifically. This draft was presented in IETF 100, and at the time it was focused on a couple of things: a new type in the BGP tunnel encapsulation attribute or extended community, and also a new sub-TLV that is used to signal from the egress P or MDE to the ingress what Geneve tunnel options are supported. So in revision 2, what we are adding is a new option TLV for Geneve that we call Ethernet option, and we are also clarifying some aspects. The Ethernet option TLV is represented in the diagram here. You have two ways of using it. If you use it with the length 0, you only have 4 bytes. You basically have the option header. If you use it with length 1, it means that you have 4 additional bytes in addition to the header. So either way, you have 2 flags that we are defining, the B and the L flag. And if you use the additional 4 extra bytes, you can also encode a source ID. What are those flags in the source ID, and why are we using those? The B bit stands for BUM bit, And basically, we needed in Geneva, we needed in the data path an indication that the payload is actually a BUM frame. So you can see an example here on the left-hand side of this slide. So if you have an all-active multi-home CE connected to, for instance, PE1 and PE2, and you have a remote PE3, let's say, for instance, you get bump traffic, you get unknown unicast traffic coming from CE3 to PE3. We do a MAC lookup, the MAC is not there, so if we have ingress application, we need to flood that frame after encapsulating it in a Geneva packet to P1 and P2. So what happens if, for any reason, P1 and P2, they already know the information for the destination MAC address? Well, what happens is that both will forward, and we'll have packet duplication in CE1. Now, we actually avoid this situation in, this is a transient situation, so as soon as P3 learns the MAC address, the duplication is gone. But this transient situation, it can take as long as the BGP advertisements, take to be propagated and so on and so forth. So we solved this in MPLS by using a different label for multicast and unicast. But in overlay tunnels, we don't have MPLS labels, right? So for instance, in VXLAN, there is nothing we can do about it. So in Geneva, we wanted to avoid that. So we are defining this bit. And then when we set the B bit in P3, basically P1 and P2, they know about it. And in that case, they can recognize that the payload is a bump packet, and only the DF will forward. So that's why we need a B bit. Ali, you wanted to add something?
Well, I just want to add a bit of clarification that the purpose of the bump bit has been described in EVPN overlay, which is sitting in the RFC editor queue.
That's true.
So we just, in here we can say that we need a bump bit because of the EVPN overlay, and this because of the same reason that we have it for the GPE NCAP, we have it for the Geneva NCAP.
Fair enough, yeah. The second bit we are defining, the option TLV, is the leave bit. And basically in EVPN E3, again, when we use it with MPLS, we have an ESI label that is indicating that the bump traffic is coming from a leave attachment circuit. So again, in we didn't have anything similar in overlay tunnels. So in Geneva, we are defining this bit in such a case that when we have an E3 kind of service, if you receive bump traffic from a leave attachment circuit in PE2, we can actually send bump traffic and avoid the situation that you have in the diagram. So if you don't have any data path indication that this is coming from a leave, PE1 would actually send to the leave and the root. If you do have an indication in the data path, you can PE1 can actually filter out the traffic and only send to the root. So that's why we have the L bit. And the final use case is when you have multi-homing for overlay tunnels. According to the EVPN overlay draft, you should follow the local bias procedures. So we are not changing that here. We are only offering an optional procedure which is similar to what we do in MPLS. Actually, it's the same procedure that we use in MPLS. So again, in overlay tunnels, we didn't have such a thing as an MPLS label. So here we are adding this source ID, which is a 3-byte field, where you can actually encode the ESI label that you signal in AD routes. And if you do that, and should you want to use that procedure instead of the local bias procedure, then you have a consistent behavior across MPLS and Geneva Ps, right? So one of the limitations we had with local bias is that you cannot have a mix of MPLS and an overlay Ps in the same broadcast domain. So with this, you could actually have Geneva and MPLS Ps in the same broadcast domain. And that's pretty much it. So basically, we'll keep working on it. We need to clarify a few points, but we would like to request comments and feedback, please.
Any question? Thank you.
Thank you.
Next speaker is Patrice.
All right. Okay, so this is going to be a bit quick. This is also a very trivial draft for people who understand what we are doing when we do port active. So, sorry, wrong side. Yeah. Okay, so if you look at the legacy story that we provided in the past, where we do full active standby using ICCP channel, usually what you're going to have is, in the case of a lag coming from your C, one of the P will have an active link, and the other P will have a standby link. And we determine that using an ICCP channel in the middle where we do synchronization. That method works for L2 services as well as L3 services. So now we have challenges because some people say, I don't want to use ICCP anymore. And if you look at the RFC, ICCP usually needs to run over an LDP session. We have, let's say if you have VXLAN or you have any other different encapsulation that doesn't have LDP, well, people are not happy to enable LDP just for doing an ICCP sync up. So we came out with that idea of creating a per interface, what we call port active load balancing for AVPN. Basically, what we are doing is we are using the EV lag portion, just the route type 4 of the EVPN framework, and we use it to figure out who's going to be the active and who's going to be the standby port. And we put a bunch of assumption about what ICCP is providing, that you don't need to synchronize a bunch of stuffs anymore. You can read the draft. I think it's pretty clear, pretty lean there. But at the end, what we are doing is, based on the EV lag, we're going to have one port which is going to be inactive and the other one was going to be in standby, or we call it out of sync, so for very fast convergence. So we have a bunch of main, there's a lot of advantages to do that. And as I said, you don't need ICCP, you don't need LDP anymore. It's very good for many technology like MPLS, VXLAN, even SRv6. It's also provide a QoS capability that otherwise you would have problems. And also it works for L2, it works for L3, it works for RB, it works in any cases. It's very in line also with the RFC, the base RFC 7432. And orthogonal to that new framework we talked about for the multi-homing. So that's pretty much it. Any question?
Jorge Rabadan, Nokia.
I know you.
Yeah, I have just a couple of comments. Are you saying in this slide that you only need the ES routes and not the AD routes, or is just my interpretation?
Well, if you don't have an EVI, if you just go L3, you won't have an AD anyway. Right? This can work just for L3 interface as well.
Right, but talking about layer 2, you do need the AD routes, right?
Yes. Yeah. Yeah. In that case, yes.
Okay, it's kind of confusing in the
Okay.
The other thing is, don't you need to define a DF type now that we have a great standard community for defining types and all that?
I'll read the framework because that was
a DF type.
A new DF type for that.
Yeah, you can configure one of the
like
keys
a load
for one
balancing
mode.
But I'll check the draft first and get back to you on that. But in my opinion, it's just a new load balancing mode as single active or all active. Now we call it port active. So.
Right, but for the TF election specifically, it would be nice. I mean, you may have like a bunch of Ps and one badly configured or whatever. So
yeah, where you need to do kind of a hash mix of IP plus ESI in this case, if you just have L3, let's say L3 services.
Right, but you are modifying HRW, and I don't see any reason why you couldn't use it with preference, for instance.
Yeah, no,
so
no,
it's
I-
kind
no,
of a
it should be-
capability.
It should work with all
right?
of that. But
So
if your
it's-
question is to add a new type to that framework, I'll have a look.
Yeah.
I'm not sure about it.
Maybe a capability will fit better.
Between the capability and the type, I think in this situation is a bit of wash, but I would lean toward the capability because the functionality that it requires is pretty minor. Is not a new algorithm because it can work with the VLAN carving, it can work with the HRW or preference. All we are doing is, if it is working based on this, we want to do it on a per link basis, you know.
Yeah, I agree with that. Yeah. And yeah, in the AD routes, basically you would signal this as single active, right? And so that the remote Ps will actually forward based on there. So there's no change
There's no
from the
change on
remote
that.
P perspective.
Correct.
Right. And also you need to make sure that the
do you want-
ACTF capability is not turned on. Otherwise it wouldn't work, right?
Do you want me to make clarification in the draft about that? I think we should, I guess.
You should read the framework draft and
Yeah.
we
Yeah,
need
let
to-
me go through it.
Okay,
and
sounds
make
good.
sure that it's
And the
being
last one is, are you driving the IRB interface state?
Hey, it's not part of my
based-
presentation, so we'll go on the next one.
No, but you have a section on the IRB thing, right? I read your draft,
Yeah.
even though you are not presenting that part. But
They asked me to cut it short, so let's talk about it. on the
Right,
next
okay.
IETF.
we can talk about it, but
You have time if you want to discuss.
oh, thank you. It sounded like you
I don't have a
guys
slide on it, Rory.
you guys want to drive the IRB interface status based on the ES.
Yes,
DF
exactly.
election?
So
That
basically,
sounds weird, if not wrong.
why?
No, I can see where you're going with that. Because multiple ESs can be on for a single BD, and you know, in order to shut off the BD, all the ESs needs to be off. So let's take that offline.
Yeah.
Did you say that for this one we need to have the DFAC off? Which one did you say we needed to have it off?
Is it about the AC influence, right?
Or preference, the preferred DF?
What I was thinking is, if you have the ACDF on, basically you are. I mean, you cannot rerun the DF election based on the AD per EVA routes
Because the full part is
because
blocked.
it's per port, right?
Yeah, exactly.
It is and of the both. It is and of both. You have it on, you configure, because that's a VLAN configuration. We configure the VLAN on both, but this is on the port basis. So whenever the port becomes active and the VLAN is active, then that VLAN is on. So this DF election is on a per port basis, and the other one is on VLAN.
But if one port is active and one individual VLAN goes down for whatever reason, we don't want to switch over to the other port, right?
Because
Just
the full
because
port
one
is blocked.
VLAN is gone.
So that's what I say is the end of the both, right? But we need to, if you're not convinced, we can have a discussion offline.
We're gonna make clarification on that point anyway. So, anything else, Rory? No? You're good. You're good. All right. Cool. Thank you.
Thank you. Next presentation is about BEM optimization. Dries is really very tall. We have a bit more time, so.
Hi, good afternoon. My name's Sandy Breeze. I'm from a service provider called Clarinet. I think there are. Hello?
Yeah.
Hi. Hi, my name's Sandy Breeze. I'm from a service provider called Clarinet. And I want to talk to you about a problem that I'm experiencing now in the wild and perhaps offer a solution to it. So my problem exists where I have multi-homed PEs on an Ethernet segment, particularly when I have more than 2 multi-homed PEs, and it's controlling bum traffic. So in 7432, where the DF election is done modulo, we have one PE that is tied to take all of the bum traffic, and to me that has a few problems. Firstly, the bandwidth in the core, which I would say that multicast flow, the draft that we've seen today, that will help me tremendously. So thanks for that. I hope it makes it. But the other problems are down to the suboptimal use of bandwidth on line card processing and the fact that remote PEs still have to go and send this traffic out to all of the people that are participating in this segment, which is just unnecessary. A possible solution to this might be to describe this function of whether we need to advertise a route type 3, so the inclusive multicast, whether we need to attract that traffic to that PE. So we might say that on a segment, PEK needs to advertise the IMET route type 3 for an EVI, if and only if he's configured on at least one Ethernet segment, which means he's multi-homed with another PE as well, and that PE is the DF for that segment. It follows that he should always advertise the route type 3 if he's single-homed. And then extending that further, any EVPN instance in a PE on the first DF Ethernet segment, the IMET should be advertised, whereas on the last DF to non-DF transition, it should be withdrawn. So here we see the initial diagram with the problem of PE1, 2, and 3, and PE1 wins the DF. The PE2 and PE3 still attract traffic in the current design. With the proposed initial solution, because they don't win the DF election, they no longer advertise the route type 3. Therefore, PE5 doesn't have to send any bum traffic towards them. In this diagram, PE4 is single home, so he still continues to attract traffic. So there are a few caveats with this. So on a DF, where PE1 fails, there will be bum drop until the next election is done and the route type 3 is flooded to reach PE5, so he knows to start sending again. But that's almost synonymous with the existing behavior because the bum is based on the route type 4 withdrawing the PEs. So if a PE went away, you have to wait for that to be withdrawn. So the convergence delay is the function of max of the type 4 and a type 3 propagation. Extending that a little bit further, we would suggest that on the segment, the PE do their election, and we have the concept of the backup DF. And we would say that where an operator agrees not to compromise the failover performance with the bandwidth that he's attracting, then the backup DF should also advertise the route type 3 in addition to the DF. So obviously the benefits of this increase with scale, where there's more than 2 PEs that are multi-homed. We're also proposing that would improve convergence for known multicast streams. So I think the draft mentions today that the selective multicast route would be sent only once, and we would propose that that be sent on the backup DF as well. Describing that would be the PE should only advertise type 3 for an EVI if and only if one of these conditions hold. So that is a single homed Ethernet segment for the EVI, and or it is a DF for at least one segment on that EVI, or it is backup DF for at least one segment on the EVI. We think this doesn't impact the convergence of the current model because the backup DF continues to receive the bum traffic. Advantages to this is that we're now imposing some additional control of where bum traffic will go. The bandwidth problem is mainly due to large multicast flows, video flows. We think that flow multicast will solve a lot of these problems, but there's no harm in withdrawing as well. The solution's applicable for single active and all active multi-homing. Doesn't require a change to the existing standards. It's easy to detect from remote PEs, and we would hope easy to interop. And the benefit increases with the number of multi-home PEs. Okay, any questions?
I'm a bit basically concerned regarding how much bang we get for the buck with respect to this. In the final solution, for the vast majority of deployment, we got the multi-homing is dual homing. So if we have dual homing, we don't get any gain, correct?
That's correct.
And if we have multi-homing, if we go back to your slide, the figure, if you have, more than one CEs multi-home for a given broadcast domain, which is typically the case, you don't have one CE. I mean, the number of CEs relative to PEs is one or two order of magnitudes, right?
So this figure probably oversimplifies my requirements.
Right. But I was basically trying to make the point, if you have more than one CEs, then the DF election tries to be fair and tries to spread the DF for the same broadcast domain among different CEs. So you're going to end up with all the PEs becoming DF.
Well, this is perhaps true for the case that you would see here. My specific problem that I have today is not quite well described by this diagram. My PE topology basically is an NVE endpoint, and I have one ES, one NVE. My attachment circuit is the NVE in each of these Ethernet segments. NVE. So these PEs facing the CE,
right?
This, basically the attachment circuit is a VXLAN. So I have one attachment circuit, which means that I have one Ethernet segment, one ESI. So I would get a nice load balancing here.
Your CE is an NVE running VXLAN?
No, between the CE, he's connected to a top of rack device, which is a VTEP. It's not drawn here because we think it still applies to the simplified case.
Your PEs are NVE running VXLAN.
Correct.
And your CEs connected to them. And how many CEs for a given VNI? For a given.
Well, the segment is tied to one L2 VNI in each case, and therefore one.
So only one.
Circuit.
There's
the Ethernet segment is only attached to that, but what you don't see is the image of that downstream from the TOR.
So there is only one CE connected to that Ethernet segment per NVE.
No, there may be many CEs.
So if there are many CEs, that's my point. Then for the same Ethernet segment, if there are many CEs, then you're gonna get the DF election. All your PE is gonna become DF because for a given, the HRW algorithm load balances it and factors in the Ethernet segment.
Yeah.
And for Ethernet segment 1, which is, let's say, for CE1, PE1 is going to be the DF. For CE2, which is not in this figure, PE2 is going to become a DF. And for CE3, PE3. So all of them are going to be receiving traffic.
I think where the confusion comes is the diagram doesn't represent my problem.
Okay. So
I
we
want to
can
clarify that. I can
we
see
can
where this
take
is
it
misleading.
offline because I've
absolutely.
had a lot of struggle, seriously, to try to understand the problem that what are we trying to solve or what are we trying to optimize. So I would love, for you to go over it and tell me.
Absolutely. So we know that the hashing is done per Ethernet segment, but in our VXLAN deployment, which is downstream of the PEs, we have one Ethernet segment tied to one VNI. So whilst PE1 will still attract traffic for, if he is the DF for the first Ethernet segment, we will never have more than one Ethernet segment in an ESI.
Okay, all right.
So we have a one-to-one mapping of Ethernet segment to ESI.
So if you have one-to-one mapping, then you don't need to do any MAC lookup. Why not use like a VPWS?
We have MAC lookups.
No, I know. I'm saying that if it is one-to-one, then you can even simplify
for
it
the
further.
segment, but for the tunnel endpoints downstream of the PE, there's many next hops and many MAC addresses on one segment.
Okay, on the other side there are many. Okay, so then in that very specific case, I can see, basically it's boiling down to you have one CE. You're saying that you have only one CE per broadcast domain, basically, because the VNI is a broadcast domain, and you're saying is one-to-one, one segment per broadcast domain.
I'm saying one segment per ESI. Yeah.
One segment per ESI or VNI? No, because Ethernet segment and ESI is the same thing.
In my world, this is the same as well.
Okay, so maybe I think still we need to have offline discussion to make sure it is the case. And in general case, I see the applicability of this very limited. In general case, for your specific situation, I think we can have an offline discussion. And if as soon as we have a single homing, either as a result of the failure, you end up with a single homing, or you start with a single homing, that PE is gonna draw traffic, period. There is basically the DF is always on, so all the optimization is at the door as soon as you have get a single homing.
I understand that.
Okay.
Satya from Cisco. So one thing I want to clarify is the figure here is not really wrong. Even if you take another CE and that CE is multi-home to the exact same PEs, right? Until now, when we are introducing the ES into the HRW, the carving is going to be same. Even if you take the 7432, the DF is going to be same for different ESS.
Per segment, yes.
Right?
Yeah.
So
you
then
can have 1,000 CEs.
So then that should clarify some of the questions that were raised.
For the baseline, I agree with you. For 7432, it is the same, but for the new DF framework, it's going to be different.
If you introduce that, yes.
No, we have introduced the idea. What do you mean if we introduce it?
No, we just mentioned that when I talked about the ES in the hash,
right?
I just mentioned that there is a specific case in which if the ES did not go into that, then that specific case is this one.
I mean, you're right. I mean, if we turn it off, then it becomes this. If we turn off the capability.
Yes.
But why should we turn off the capability if we can do it?
Even today, it's not the same PE.
Speak in the mic if you want to speak.
No, and this is talking about with respect to a given.
Can you just repeat what has been said?
Okay, so this is Wen from Juniper. So I was commenting on even the DF election algorithm.
Speak in the mic. We can't hear you. So I'm sorry.
Even the DF election algorithm based on the IFC 7432, we will not end up with the same PE as the DF, because if we have two different ESI Ethernet segment, if their bridge domain are different, the modular is based on the minimum VLAN ID, so will be different.
No. But we are talking with respect to a single BD.
Single
yeah, the whole.
You could have a different
No.
BD.
The context in here, the prerequisite is single BD. So with respect to a single BD, question is if we have multiple CEs on 7432, currently all CEs, the DF for all CEs for that BD maps to the same PE.
That's true, because
And I'm saying that problem is solved with the DF framework draft.
Well, I think.
But he is talking about a special case where there is one CE for that. There is not multiple CEs for a given BD. There is only one CE for that BD.
So he has static VXLAN network on the other side. So it's like a VXLAN network multi-home to the EVPN. So it's similar to one CE in this use case. I see what you said. Yeah.
Okay, let's move to the other questions.
Thanks. Jorge Rabadan, Nokia. Yeah, I also have some doubts about the applicability, but okay, if you have a strong use case, all right. My only comment is that this is just based on the advertisement or withdrawal of the IMET route. So it shouldn't be informational rather than standards track. I already discussed it with Satya, but to me it's more informational.
Okay.
Thanks.
Robin from Huawei. Robin from Huawei. I checked my. We happen to see that is 4 years ago, also in London, we proposed another draft. At that time is L2 VPN working group. I think that we try to cope with the similar use cases to reduce the.
Sorry, which draft are you talking about?
The L2 VPN, L2 VPN multicast state advertisements. That's draft. Maybe I will send it to the mailing list. Okay, I think that we try to cope with the similar issue to reduce the useless the traffic for the multicast. On the other hand, the different solution, we try to advertise the state for the active and the inactive, because we try to the solution hoped to because in the ingress when set up the P2MP tunnel for the inactive the tunnel, we maybe can set up some this the backup. Okay, so that's so later we try to if we consolidate this possible. Okay.
Okay. Thank you.
May I? Well, there are some similarity, but I think the wires are getting crossed here because we are talking about different things. In the proposal that you're talking about is basically on the ingress side, we try to optimize it and not sending it. And this was something that if you go back to the version 0 of the EVPN draft, and I'm talking about the individual draft. It was mentioned there, and we decided to take it out. So, whereas what he's talking about is different. He's talking about doing it on the egress side and not advertise the IMS. So there are different, is for different scenarios. And the use case in here, again, is very specific. So we need to validate the use case. And if that use case has merit, then that's fine.
Okay, thank you.
Please be very quick with your question.
One line. So, yeah, we are okay with it being informational if community thinks like that.
Thank you.
Do you want an EVPN sticker?
Give him two.
Please come on after the meeting if you want one. So last presentation, Satya.
Yeah, this is it's not EVPN related. Yeah, so this is the work that we did with Google sometime back, and this has to do with the DMZ load balancing. So that draft, the DMZ link bandwidth extended community draft, that went through several iterations, but at some point I saw that it's kind of expired, but most implementations had it. And we had a requirement in the Google network to use that. So, bless you. Thanks to AC Lindem, he said that we should revive that. And then we use it for our purposes. So it's it is good to refer to a draft which is still active. So where is the requirement? The requirement was, so I'll go to the picture in a minute. But the link bandwidth extended community actually encodes the bandwidth of the egress link, and then it is sent in the BGP update to the IBGP peer. And consider that the same prefix is reachable from 2 or more egress eBGP peers. On the IBGP side, you can do a load balancing based on the link bandwidth community, and the link bandwidth community can encode the bandwidth of the link, or you can set it via policy. So therefore we say that it is useful in load balancing across inter-AS links where the same prefix of the net is advertised into the receiving AS. So here you have a simple topology in which C1 is advertising the same route, let's say, to P1 and P2. And the P1 and P2, they can encode the value of the bandwidth in the link bandwidth extended community and send it to P3. So when P3 sends the traffic, it can load balance in the ratio of 1:2. Now this extended community is optional, non-transitive, so it doesn't go across ASS. And it's not set when the next hop is set to self. Also, all the paths that are associated with the link bandwidth community, if all those paths are considered as multipaths, then the better all of them should have it. Okay, and then this is taken by account by the fib or like the forwarding, and it does the load balancing there. So this is the simplest simple representation that I've shown, in which there is an address sitting under the TORs, and that address is reachable by, that IP address is reachable by all of these TORs. So these TORs, they are in one AS and they are connected to spines, which is in other AS, and then this is an all eBGP network. So you can see that TOR1 and TOR2 will generate the link bandwidth extended community with value 100 and 200. So this is, I forget, but I think it is in bytes in the, as it is in the encoding. And then the spine can accumulate that and it sends it to the TOR5. Similarly, from TOR3 and TOR2, the same advertisement, like the advertisement for the same prefix is sent and the link bandwidth is encoded, and then the spine 2 can do the aggregation and send to AS300. Now today there is, so there is no way to accumulate this link bandwidth and send it. I mean, this is a standard problem with BGP extended like attributes, right? In general, that maybe I shouldn't digress there, but So there is no way to accumulate this. And this is an optional non-transitive. So the semantics is not completely in line, because now we want to advertise it across the eBGP boundary, but it's not really the same attribute that is being sent. We are like regenerating it. So so we need some new config knobs for this kind of, I mean, I call it draft violation, but it's kind of immediate. And so existing customers can continue to deploy the link aggregation or whatever is in base implementations, and they do not need these knobs. So as an example, we had some new, I'm just giving this example as Cisco IOS XR as a vendor, that there were 2 knobs that were implemented for this to do the accumulation and send it on to whichever eBGP neighbor you are advertising. And on the receiving side also, you had this knob to allow the community to be accepted. The default is it will drop it. So there is some other thing that one needs to take care, like so this has to be, if you see from the point of view of the destination, the entire graph has to look like a directed acyclic tree, meaning the contribution of the community by whatever means should not be factored more than once. I have explained in the draft, I think. Yeah, so that's pretty much it.
Just on your North networks, I don't think you need to create knobs. You need to update the draft. And the draft was presented either last IETF, one before, and I think we brought up the fact that the attribute is non-transitive. It needs to be changed. So let's change it, take it to IDR, and be done with it.
Which draft was presented? Sorry.
The DMZ.
That got updated, revised. I mean, that got revived just now. That doesn't talk about cumulative link bandwidth at all.
It does, see. And it belongs in IDR anyway, not here.
This is, okay, there is another draft. I'm talking about Rex and Pradosh's draft.
So what Jeff is talking about, Jeff Oz, is that the link bandwidth draft that this originally started from, you guys revived.
Yes.
That's good. What he's saying is that that's already there. It's permissible for non-transitive extended communities for you just to simply re-originate it. So you're basically making it look like a transitive. It's not really.
Right.
The interesting caveat here, and this is something that Juniper is going to have to respond to anyway, since the draft bubbled back up after, I think, 7-8 years of being dormant, was the fact that we deploy transitive versions of this community, and we don't use the non-transitive version.
Well, you made it transitive?
Yeah, so yeah, and unfortunately that leads us with code that's not compatible to interop at the moment. And this was something we were going to actually approach the authors about for this. Additionally, on top of all that, we implement this feature right here already. This is part of an upcoming release.
I missed the last part. What did you say? You implemented
the accumulation of link bandwidths.
Okay, so
one of the we do have a strong caveat to offer here. We didn't actually bother with the draft simply because, from our perspective, it's a local router behavior. But the caveat that we would offer is that link bandwidth is similar to a lot of what I like to call magic communities this group has a tendency to spit out, where you expect exactly one of them. If you think about how communities typically operate, you compare them as opaque 8-byte values. Think about what happens when you have more than one link bandwidth community inside of your a box. What does it actually do? So as part of doing this, the guidance to the developers were, we should use one of them and make sure that we only ever send one along. So
the point I take from you is not to do away with the knobs and make the link bandwidth transitive. That should solve it, right?
Still we need cumulation, right?
So
we still need to do the
yes, so there is how will we distinguish between, it's the classic problem, right, with the attribute. Like I receive an attribute, I modify it and send it. Now I have no way of knowing whether it actually came with that value or I modified it.
Oh, sure you do. It's like if it's in the case of the non-transitive version, if you don't touch it, you follow the rules of re-origination. You know,
But-
that part's an internal code detail.
Right, but if you touch it, then the receiving guy, he won't know, right? Who changed it? How will you know?
How would you not know? It's
If I may,
please.
Thank you. So I think the
Please
problem
state your
that
name.
Alice Josie. So the problem they're trying to, it is very, is incremental to what it was before to the link bandwidth. So, and is a small increment, and the small increment is the middle hub that gets these link bandwidth through this previous one, add them up together, and for the transitive case, add them up together and send it up. And that is not mentioned in the previous draft. And we had two choices, whether add a paragraph to the, or add a section to the previous draft, or have a new one. But because there were different authors, this one was the easier
Yeah, we actually
road to move forward.
we had
Yeah, there's nothing stopping you from the core link bandwidth draft, with it being non-transitive, from functionally treating it as a re-origination, which effectively makes it look like transitive. But it's no different than if you and I speak eBGP and I send you one of these communities.
Right.
The request from non-transitive is that as part of receiving it, you do not propagate it to your other ones. Very similar to BGP no export. So that's the behavior we expect out of non-transitive extended communities when you inject it at eBGP point.
Yeah.
So in terms of that piece of procedure for non-transitive in your draft, I don't think there's anything new needed. I think it's covered. I think for part of your case about wanting transitive behavior, like I said, we already implemented it in Juniper, and we have to approach the authors about getting that updated in the draft anyway. So there'll be a transitive and non-transitive version of this link bandwidth. And the accumulation behavior, it's, I think, a reasonable thing to document, and we're happy to join with you on the draft since we are implementing that already.
Okay, all right, thanks.
We already have an implementation use
Yeah,
case.
we can. Thank you.
Thank you. So this is the end of the session. We have a lot of documents in our backlog for working group last call and working group adoption. We will try to prioritize them and proceed them as soon as we can. So see you in Montreal.
And if you have the other blue sheets, could you bring them to the front, please? Jeff.
What is the final outcome? Going to extend it or not? Charter.
Yes.